My topic is the proof of lemma2 in circle stack paper. Let's see. My English is not very good, so the lemma2 set a subset D. Let me write this. A subset D of the complement of GM. I will write this like this. Complement of GM. GM is a subgroup of order 2 to M. Okay. D is the subset of the complement of GM. And if D is invariant under Gm minus 1 and J, the inverse map J. If D is invariant under Gm minus 1 and J, then D can be decomposed into twinkle sets of size 2 to n with any n less than or equal to n. Then D can be composed into, maybe I should add a word, evenly. Can be evenly decomposed into twin cosets of size 2 to n with any n less than or equal to n. This is the general case of lemma2. And the special case is the one Eric just showed to us. When D is a standard Palladian coset, that is a special case. And the general case, we don't need D to be the standard Palladian coset. It just needs to be a subset invariant under Gn minus 1 and the inverse map J. And now I will prove this lemma. The proof includes 3 parts. The first one will be the claim 1. Claim 1. D must be a union of cosets of Gn minus 1. D must be a union of cosets of G minus 1. I think I will not prove this claim very formally, but I will give some proof hint. This is from this claim. It can be directly 推导怎么说 ？How to say 推导？ This claim can be directly derived from D is invariant under Gn minus 1. let us assume the set D look like this. Assume the set D look like this. Then, because D is invariant under Gn minus 1, so A times Gn minus 1 must be in D2. So we can rewrite D as this.
What is invariant?
Invariant. Any D is invariant under Gn minus 1 means any element A in Gn minus 1. We take any element A in Gn minus 1. Then we multiply A to D, to any element in D. Oh, I should write this. Any element A in Gn minus 1, we have A times D equals to D. Oh, I should write this. It means this.
So D remains unchanged.
Yeah. Then continue this. Then we can rewrite D as A times D, and like this. And we can continue do this until we write D as this. And S will be a set. Oh, no. No, this should be Gn minus 1. Yeah. So D must be a union of coset of Gn minus 1. Okay.
What's S?
S is a subset of what? Of circle curve. Like we bring all the elements in D into S. Okay, this is claim 1. Then claim 2 will be if D can be decomposed into twinkle sets of size 2 to n, then D can be decomposed into twinkle sets of 2 to n with any n less than or equal to m. If D can be, I will leave these things. Let me write it as formula. D equals to, no, union.应该是 Q I Z minus 1. Yeah. Q Z minus 1. This formula means we can decompose D into twinkle sets of size 2 to n, right? We have just proved that D must be a union of cosets of G and minus 1. So the size of D must be some t, the size of D must be some t times 2 to n minus 1. So this should be 2. Okay, is that right? We should be right. Okay, claim 2 is if we can decompose D into twinkle sets of G, or twinkle sets of size 2 to n, then we can decompose it. Then we can decompose D into let me change PQ. I should no formula. I will write words. Then D can be decomposed into twinkle sets of size 2 to n with any n less than or equal to m. I will prove this. Because we have G m minus 1 equals to, we now decompose the subgroup G m minus 1 into 2 parts, like G m minus 2 union some P G minus 2. I will prove this next time. And I remember Yu Longding proved this in last week demo day. Yeah. So we just substitute Gn minus 1 in this formula. Use this, substitute Gn minus 1 in this formula. Then we get这个高度。Q A G
The chair.
Okay, thank you. Q equals to Q I G M2 union Q I inverse of Q I G M minus 2 union Q I P M minus 2 Q M minus 2 union Q inverse of Q P minus we can see the first part is already a twinkle set, but the size is half. And the left part, it should be a twinkle set, also with size half, but here should be Q I P p n minus 2. So we need to transform this into this. But actually we can, this 2 is equal. Qi, inverse of Qi times p n minus 2 equals to Qi times p n minus 2, the inverse. Why? Because of this, from this formula, p n minus 2g equals to, because of this, so this one equals to this one. If we have enough time, I will prove this. Now we just take it as a what? I don't know, use what words.
Conclusion.
Yeah, just use it as a conclusion. It is derived from this one. The order of this one is 2. Later, if we have enough time, I will prove this. So we can see we just decompose every twin coset in D into 2 twin cosets with size B, with half the size. Yeah, we just half the size of twin coset and double the number. And we can continue to do this. So we can decompose D into twin cosets of any size 2 to n with n less than or equal to n. This is claim 2. Now we just need to prove we can decompose D into twin cosets with size 2 to n. Last part. The last part shouldn't be clear. How to prove? Let me think. Now we want to prove D can be decomposed into twin cosets of size 2 to n. We already, from claim 1, we already know D is the union of cosets of G n minus 1. So we just need to prove every coset Q G n minus 1 in S is all. Every coset G n minus 1 in D, there exists a twin cosets of not twin cosets, just cosets. Say coset Q, inverse of Q times Gn minus 1 in D. Yep, if we prove this, then we proved D can be decomposed into twin cosets with size 2 to m. Then, how to prove this? We can prove, we need to prove for any element A, let me write little a in G n minus 1. I should be A. Let me write big A. I'm familiar with big A. There. exists. There exists q minus 1 a. Yeah. There exists q minus 1 a in D. Let me check. I'm not very sure. This corresponding to the element Q. Let me write some more words. So, corresponding to Q. A in Q G minus 1. Yeah. There for all A in G n minus 1 corresponding to Q times A in Q times G n minus 1, there must exist Q, the inverse of Q times A in D. If we does this make sense? Okay. We can see we have this one we have used D is invariant under J, and now we will use this to prove this. Because D is the union of the cosets of G n minus 1. So if QA in D, then Q times inverse of A must be in Q2. Must be in D too. This makes sense? Because G n minus 1 is subgroup, and subgroup is closed under inverse. So QA in D, then Q inverse of A must be in D too. And J of Q inverse of A just equal to inverse of QA. And then we proved this. This one, I will write the formula to prove this.
Xiaoxue time is up. How many times?
Should I continue or give me 2 minutes to write the last formula? Why this is correct? 2 minutes. Because Q times equals to Q times X equals to and Q inverse of Q times A equals to inverse of Q times. This just the same as the multiplication of complex number. As you can see, these two, they have the same x coordinate and the inverse y coordinates, and so they are. So this formula is correct. I'm done now.